Hi there, I'm Dimitris Harlabidis, and in this video, which is part of a greater series of videos focused entirely on the AP Precalculus syllabus, we will talk about a huge concept in the AP Precalculus, the one of the average rate of change. And we will begin by defining the average rate of change of a function. From now on, it will be simply notated as AROC over an interval a and b where the endpoints a and b are included. Now, given a function, how could we, let's start with the conceptual thinking. Given a function, how could we measure how fast the values of this function are changing between 2 points a and b? That is exactly what the average rate of change does. In order, based on this, following this thought, in order to do such a thing, to see how fast the values change, we would need the slope between these 2 points. So, based on that thought, the way we defined the average rate of change over an interval A included, B included, is that the average rate of change is f of B minus f of A over B minus A, which is exactly the slope. And then here, for instance, in the geometrical interpretation of the AROC, given a random graph and knowing that this is the point A, f of A, and that this could be a different point with coordinates B, f of B, we said that the average rate of change over AB is f of B minus f of A over B minus A, which is nothing else than the slope. It's the slope of the line passing through these 2 points, through the points A, f of A, and B, f of B. It's an easy definition, it's an easy formula, and it's something that we expect to definitely see in the upcoming exams. You should all know how to calculate the average rate of change over an interval. Now, let's work together, or before we do that, before we work some examples, let's see in word problems how it would look like. In word problems, the average rate of change describes how one quantity changes on average compared to another quantity over a specific interval. It is often interpreted as how much does the output value, that could be the distance, that could be the cost, that could be the temperature, how much does this output value change for each 1 unit increase in the input, where the input could be time, could be people, could be items. In general, remember that the average rate of change shows it's the slope. And by the way we have interpreted the slope shows the change in the y value every single time the input value, the x value, increases by 1 unit. Now we are ready to work some examples together. Find the average rate of change of f of x equals x squared plus x from x equals 1 to x equals 2. All that I will do is simply apply the formula f of 2 minus f of 1 over 2 minus 1. I will go here and I will separately calculate these values. 2 squared plus 2 should be 6, and 1 squared plus 1 should be 4. So it's 6 minus 2 over 1, which is equal to 4. In the next one, find the average rate of change of g of x, which is now defined by x squared minus 2x on the interval -1 closed, 1 closed. So the average rate of change in this time is g of 1 minus g of -1 over 1 minus -1. Once again, I will go somewhere in a corner and calculate separately these values. It's 1 squared minus 2 times 1, 1 minus 2, it's -1. And g of -1 is minus 1 squared minus 2 times -1. So it's 1 plus 2, it's 3. Which means g of 1, -1, minus 3 over 1 plus 1. So it's -4 over 2, it's -2. Which means that for every single increase of 1 unit on the input value from -1 to 1, the values of the function change on average by -2, which shows that they are decreasing. In the following example, in the one you have in front of your screens, we are not given the function's notation, but we are given the function's graph. And yet again, we need to calculate the average rate of change over an interval. Again, there is only one formula for the average rate of change. Let's assume that this is the graph of a function f of x. So it would have been f of 2 minus f of -4 over 2 minus -4. F of 2 can be seen from the graph. When the input value is 2, the output value is -2. So the f of 2 is -2. F of -4, when the input value is -4, the input value is 4. So f of -4 is 4 over 2 plus 4. So that would be -6 over 6, which is -1. Next example and final for this video, it's a word example. A hiker records the elevation of their hike at different points in time. At 9 a.m., the elevation is 1,200 feet, and by 11 a.m., the elevation is 2,000 feet. Calculate the average rate of change in the hiker's elevation per hour between 9 and 11. Okay, so we assume that we have a function that gives the elevation in terms of time. So we could assume that the 9 a.m. and this can create this point, while the 11 and 2,000 feet could create that point. So now that I have 2 points, I am ready, and assuming that we named that function as f, we can simply do f of 11 minus f of 9 over 11 minus 9. That would be 2,000 minus 1,200 over 2. 800 over 2, that would be 400. Now, in terms of the given context, how would we exactly interpret that average rate of change? We would have said that on an average, it seems that every single time the hours increase by 1, so every hour, the elevation increases by 400 feet. And that would be all. Remember that this concept of the average rate of change on an interval AB is a hot, let's call it this way, a hot concept for the AP Precalculus. We should expect to have at least one question focused on that. In a simple way, calculate the average rate of change. Make sure you understand that. I hope this video helped you out throughout this process. If you found indeed this video helpful enough, don't forget to like and subscribe. As always, Thank you for watching and thank you for your time.